just to fill you guys in, we covered all of these slides, and there was about 50 of them. Some of that is just me, what we're going to be doing in this project. We're going to be building a little maze solving robot. We covered some simple circuits, what an Arduino board is, which is just kind of the thing that we program to do little bits and bobs. We covered some PWM, and we covered how to do some breadboarding as well. And then we covered pseudocode and generally how to program an Arduino with your declaration. So you have your variables, then your setup in the setup loop here, and the loop. Don't worry if this doesn't make sense to you now. Obviously, if you go back and watch previous weeks, it will. And this is kind of our generic maze solver robot. So we've got our 3 sensors that we're going to look at now, 2 motors, and some little bits of circuitry in between. Okay, then we covered a little bit of the circuitry, which is the H-bridge. This is the key and critical bit that you guys need to learn. And basically all this does is controls 2 motors, one motor on this side and another motor on this side. Okay, we then wired these up last week like that, and that is the chip, and these are the 2 motors, one on this side and one on this side. Wired those up, and we did a little bit of programming. Does everyone remember running our motors?
Yeah.
Thank you. That was an ecstatic yes. Okay. Then needing to know bits, we covered some arrays, we covered serial printing to the monitors, we covered if statements. Now we'll be doing a lot of if statements today, so I am going to just clarify this. Basically, an if statement. Does anyone not know what this is before I explain it? Again, does anyone not know what an if statement is? Don't be shy.
Can you say it, please? Can you explain it, please?
Right, perfect. Yeah, let me put this over there. That's fantastic. Okay, an if statement. Basically, an if statement is just an if, right? We say if, and then we check this criteria here, this statement. This statement says my value, a value that we've given here, and we check is equal to 10. Okay, we say if my value is equal to 10, right? If this statement is true, we will execute the code in between these curly brackets directly below our if statement. Okay, otherwise, and I like to call it otherwise, but realistically it's else. If else, we have an else statement here. If this is not true, we will conduct this piece of code here, right? So if my value is equal to 10, we will print to our serial monitor, my value is equal to 10. Okay, if it's not, then we'll print out my value is not equal to 10. Everyone happy with that? Right, we'll then also have an else if statement, okay? So we had our else before, but now if we put an else if, we check another criteria. We can say, if my value is equal to 10, I want to serial print this out, my value is equal to 10. Otherwise, if my value is equal to 11, serial print, my value is equal to 11, right? So we're adding in another statement, okay? And this all happens in a sequence, right? We start from top and we go all the way down to the bottom. Everyone happy with that?
Yep.
Yeah.
Cool.
Yes.
That's it. Thank you, guys. That's what we want. Right. And here are some other operators. So it's not just equal to, we can also say less than, greater than, not equal to, and so on. We'll be covering this later. We then also introduced ultrasonic sensors. Okay, they look like these little googly eyes. They have a transmitter and a receiver, right? They are called the trigger and the echo. Okay, so the trigger is triggered here. Sorry, it has 4 pins. Okay, I'll explain this again. Has 4 pins. The left one in red here goes to our 5-volt rail and powers the actual device. The negative black line completes the circuit and again powers the device. The yellow one is our trigger. Okay, the yellow one is our trigger, which emits the signal, the ultrasonic signal, and the echo is connected here in green, and the echo receives our reflected signal, right? So ultrasonic sensors emit a signal and then wait for that signal to come back. You've only missed 1 session, but we covered a lot. Distance sensing, basically if I yell at a wall and then wait to hear back my yell, I can calculate how far away that was using the speed of sound. Okay. So what we have to do is we have to send a trigger pulse, a 10 microsecond trigger pulse to the trigger pin, which is our yellow one. We send that from our Arduino. The pulses are then sent here. And then on the echo pin, we wait to receive that echo back on this echo pin. And when we receive that echo pin back, we calculate the time it took, and we can then calculate the distance. Okay. Does anyone need me to explain further how an ultrasonic sensor works?
I think it's all right.
Yeah? Don't be shy.
Yeah, no, keep going.
All right, cool. That's what we like. Right, so basically then when we got to here, so we all wired it up, I say, an ultrasonic sensor like so, okay? Just like the diagram before, yellow and green wires just to make you feel at home. And I'm going to do this on the right Arduino this time. And here we can see our initial declaration. We're telling the Arduino where we connected our pins, the trigger pin and the echo pin, to pin 7 and 3. Oh, there everyone is. Welcome back, everyone. Remember, microphones off, please, unless you've got noisy neighbors. I want to hear your voices.
Other way around.
Why do I keep saying that? Okay, microphones on, please. Unless you've got noisy neighbors and it's going to be too distracting, please, I want to hear you guys talking. I want to ask questions. I want all of it, okay? Right, so we've got just doing a recap for anyone that's just joined, what we did last week for the newcomers. Right, so recapping. We have our trigger pin and our echo pin connected to pin 3 and 7 on our Arduino. We then have our setup loop where we start our serial connection to our computer so that we can see things. We set the pin mode. We tell the Arduino that the trigger pin is an output and the echo pin is an input, okay? We then have our loop here. And what some of you didn't do, I don't know if anyone actually got round to doing this last week, but I'd like you guys to be doing this. So while we're here, while I'm recapping, we then have our system as we spoke before. Remember this bit, this is critical here. We have to trigger our pin. We have to tell the sensor to emit a signal using a 10 microsecond trigger pulse. Okay, and then we're going to wait to listen on our echo pin. What does this look like in code? It looks like this. First, we clear our trigger pin. We make sure there's nothing on our trigger pin. So we set our trigger pin to low. Okay, we then put it low for 2 microseconds. We then create our 10 microsecond pulse. So we send it high. We wait 10 microseconds and then we send it low again. Okay, so we're sending our trigger pin high and then low. We then return the distance value is equal to pulse in. This is a function that basically counts how long until we get a high signal on our echo pin. Okay, that is counting how long until we receive that signal back, which is equal to our distance. We then return distance multiplied by this fancy number, which is just somewhat to turn it from speed of sound into an actual measurable distance. And then when I start the simulation, you're all going to be amazed. I open the serial monitor. And here you can see that this little ball, as I move it closer and further away, changes the values that we see on the monitor. Okay, so this here is saying 58 centimeters. We're seeing 58 centimeters. Move it further away, 123, 120. Okay. Now, what we didn't do last time is we didn't look at, I think we didn't look at functions. Did we get to functions yet? No. Okay. So what I wanted to show you guys is that we can do what we've just done. But if we want to speed things up, we're going to involve a function. Okay. So before we declared our variables, we declared our setup, and then we have our loop, okay? But in the loop, we can jump out. I think I'm getting some echo from Baiz. Feedback from Baiz. Yeah, thanks. So in the loop, we can jump out to a function, which is exactly the same as setup and variables, but we can write our own bit of code to be called in there. Okay, so that's what I've just done in my program. I've created this function here. Okay, can everyone see that this is separate from our loop? Okay, in our loop, I'm literally taking the distance and I'm printing it out. Okay, which makes this very, very short. This is looping over and over again. And in our loop, we are calling the function that I've made ultrasonics, right? This function is called ultrasonics, and it involves taking in two signals, our trigger and our echo. Okay, and then our digital write, and then we do all of our thing and we return the distance. Okay, distance is equal to ultrasonics. We put in our trigger pin and our echo pin, right? And then we're going to print out our distance. So can everyone see that we're looping through this? We're calling our function. We're putting in both our trigger and echo pin. The ultrasonics function is taking our trigger and echo. It's performing the trigger. It's taking in the reading. It's returning its distance, right? It's returning the distance, which we then make equal to our value distance here that we print out. Okay, so you can see this. It goes loop, jumps out, does the ultrasonics code, comes back here, prints it out, loops again, comes back here. Does everyone get the concept?
Yeah, it's good.
Yeah, cool. Right, what I'm going to try and do now is, can everyone try and wire this up in their program? And I'm going to try and put the code in the chat like that. I want everyone to have wired this up, okay? So this is what we had last week set up. If anyone does have their sensor connected up to their H-bridge, well done from last week, although we've got a lot of fresh faces. So I'm just going to show you guys what we've done. Obviously, this will make sense if you go back and review last week's. So I'm going to switch to my second Arduino here with my second lot of code that looks almost exactly the same, although in this case, we're controlling these two motors, okay, using this H-bridge. This H-bridge, the left side is controlled by my two green pins. The right side is controlled by my two purple pins, okay? So this will become clearer. We're first going to, as well as having our trigger and echo, we're going to declare our motor left pins, 3 and 4, which are our green ones here, and our motor right ones, right 1 and right 2, which are connected to 6 and 7 over here, okay? Then, as well as before, we have our echo connected. We have to tell the Arduino, once we've connected these pins, what are they actually supposed to do? Are they inputs or are they outputs? Okay, again, this will become clear if you watch last week's video. We're going to tell them that they're all outputs. So we use our pin mode. We tell it that motor left 1, 2, 3, and 4 are all outputs. We're going to output signals to them to tell the motors which way to run. We then have our exact same code here. And then in my loop from before, I've now added this piece of code, and I don't know why it's come up with little red lines, but it has. It basically says if, and remember this if statement that we used from before. For anyone who wasn't here at the beginning of the session, does anyone not know what an if statement is? Feel free to say yes, and I will explain it. Otherwise, you will be confused.
I actually didn't know what it is, so it's fine with me.
No, I don't really know fully.
Okay, that's
I know
fine.
it's a condition, but
It's a condition, and so we're going to explain it one quick time. If we put an if statement, we're basically checking if something is true. If this statement, my val, is equal to 10, we're comparing my val, which could be anything, is equal to 10, this number, then you will conduct this code, right? You will conduct the code between these curly brackets. If my val is equal to 10, conduct this code, okay? Otherwise, else, if this isn't true, conduct this piece of code, okay? My val is not equal to 10. We're going to print out, right? That is a if statement. That is it in its simplest form. You can also whack in an else if, this extra little blue bit here. We can say if my value is equal to 10, conduct this piece of code. If this statement is true, conduct this. Else if this statement is true, this new additional statement, you're going to print out this. So if my value is equal to 11, we're going to print out my value is equal to 11. Otherwise, serial print, my value is not equal to 10 or 11 in this world. Let's actually make this correct. Okay, so that is an if statement. Now we've used it in this criteria to say that if our distance, the value that we've returned from our ultrasonic sensor, is greater than 40, if our distance is greater than 40, we're going to set our motors like this, okay? One high, one low, one high, one low, okay? What this is going to do, and if you watch last week's video, if we have motor left 1 and motor left 2 set to different things, the motor will spin, okay? If we have them set to the same thing, in this else statement, the motors will stop, okay? So motor right 1 and right 2 are different. One's high, one's low. So the motor on the right is going to spin one direction. And because we've set them the same here, it's going to stop. If I run this simulation and wait for the computer to pick up. Okay, so can everyone see here? Very, very small. There's some numbers down there. It says 143. If I now click on this ultrasonic sensor, let's try and make this clearer for you. If I now click on this ultrasonic sensor and move that value below 40, those motors, can you see, have dropped to 0, okay? So this is us fulfilling that criteria. We're saying the distance is now less than 40, the else statement. All those motors are set to 0, okay? The motors do not run, okay? We go again, above 40, this condition is true, the motors now run, okay? Is everyone happy with that? All right. In your case, what we're going to do is we're going to connect up 3 LEDs, or let's set up. How can we do this so that you can get it quick? Because I don't want you guys wiring up a H-bridge. Let's get you guys to grab an LED, everyone. So type in. Oh, why does it do that? Type in here, LED. And I want you to grab an LED from there. Okay, you're going to connect this bendy leg that's called the anode to pin. Let's send it to pin.
Sorry,
30.
Ben.
Yeah.
How do I exit this editor and go back to the list of components?
Press code up here.
Okay.
It should be highlighted in blue. You click it and it should disappear. I want you guys to connect up your LED like this. Okay. Can everyone give me a raised hand when they've managed to do that so I can make sure that people are following along? Now you're going to grab another one and you're going to connect the cathode again to ground and you're going to connect the anode to 12. Okay. So same thing, but you're just going to connect it to 12 this time instead of 13. Now in your code, this is your code that I've given to you. I want you guys to copy what I write. Okay, you've connected up those 2 LEDs. We're going to copy what I write. Okay, we're going to first declare that we have 2 LEDs connected. Int LED, we're going to give it a name. 1, LED 1 is equal to, it's connected to pin 12, semicolon. Int LED 2 equals pin 13, semicolon, right? Copy these 2 lines up exactly where I've put them. Okay, hands down, hands back up if you've managed to complete these 2 lines. In our setup, we're going to write pin mode, capital M on mode, not capital O, pin mode, open bracket, LED 1, that's the name that we gave it to it before, comma, output, semicolon. Okay, can anyone guess what we're going to do now? We're going to copy that line and change that for LED 2. Okay, what we're basically telling the Arduino is that we have LED 1 and LED 2 connected as outputs to our Arduino. Okay, so please copy these 2 lines, hands back down, hands back up when you get it done. Right, now in your loop, I want you guys to copy this. If open brackets, we're going to now make our statement. We're going to say if the distance that we've just collected, if, and you're going to spell it right, if distance is greater than, let's go 50. If distance is greater than 50, open bracket, and these have to be curly brackets, people. Open bracket, close bracket. We're going to say digital, capital W, W right, open brackets, LED 1, high. Okay, semicolon. Right, so we're going to say if the distance is greater than 50, set our LED to high. We want to send 5 volts out of our digital write signal to our LED, and we'll turn it on. Otherwise, so else, I don't like the fact that they called it else. I wish they called it otherwise. Otherwise, you're going to copy this piece of code because you're a savvy engineer that knows that copy and paste is your best tool. And you're going to put low, right? So what we've said here, I'll give you a second. Hands down, hands back up when we've all got it sorted. All we've said here, guys, is in our loop, this loop is going to constantly run. We're going to, in our loop, we're going to say distance is equal to the result we get from our ultrasonics function, which returns a distance from the sensor. We're then going to print out that distance to our monitor. And then we're going to say if that distance is greater than 50, turn our LED on. Otherwise, turn our LED off. Okay, so once you've got these, what, 1, 2, 3, 4, 5, 6, 7, 8 lines of code done. Why that took me so long to count. Once you've got your 8 lines of code done, put your hands up. Now, one thing I'm going to teach you now, as quickly as possible, is how to do this for multiple sensors. Okay, because in no system, well, in hardly any system you're going to have, do you want to be reading just one sensor. Okay. Now, it's useful that we've run this in a function, okay, because now we can call our function with something else. Okay, so what we're going to do is we're going to stop our simulations, put our code away for a second, and you're all going to take your ultrasonic sensor, copy and paste it, and you're all going to make a second sensor connected up like this. We're going to take our power line, and we can connect our power to the same thing. And we're going to connect our power to the 5 volts. Okay. We're going to connect our ground to our ground over here. Okay. Anyone not following? No? Okay. You're then going to take your trigger. Okay. You're going to take your trigger. It's a nice green little wire. And you're going to connect it to 6, okay? You can connect it to whatever you want, but it's easier to follow along. If you want to challenge yourself, go ahead. Okay, and we're going to take our echo, and we're going to connect our echo to pin 4. Let's connect it to pin 4 for safety. Okay, and we're going to color that yellow. Okay? Hands up when you've managed to connect it up, just like Ben. So we're going to open up our code. You're all going to lower your hands for me so that we can ask the next time. Okay, so in our code, right, we now have a second thing. So again, we're going to work through our simple steps, starting at our declaration. Okay, so the first bit, we now need to say that we have another trigger pin and another echo pin. Okay, so we're going to copy and paste that. And we're going to call this one trigger pin 2 and echo pin 2 because we're cool. And then we're going to call our trigger pin 2, right? Trigger pin 2 is on our second ultrasonic sensor, is connected along this green wire. Let's follow it along to number 6. Okay, so we're going to change that one, and we're going to tell the Arduino trigger pin 2 is connected to pin 6. Echo pin 2. Can anyone tell me what echo pin 2 is connected to?
4 for safety.
4 for safety. That's fine. Yeah, I love the way you copied that. Okay, so it's connected to pin 4. So we now told it that we have our trigger and echo pin 2s connected to these pins. What are we going to do next, people?
The pin mode thing.
Pin mode, right? Pin mode, exactly. So again, we're going to be street smart, and we're going to copy and paste that. What do we have to do though? What's the problem here?
Oh, trigger pin 2 and echo pin 2.
Well done. Thank you. Top marks for Umar. Someone's been listening. Right. So we've needed to call them trigger pin 2 and echo pin 2. Otherwise, we're just calling them the same thing. And we're calling these ones here. OK, I'm going to move this down here for clarity so that people can see this. Space my code out a little bit. Okay, so now we've told it that it's an output and an input. All right, what we're going to do here is we're going to copy this line again because we're street smart. And what are we going to call this? We don't want to override our distance. So we're going to call this distance. Guess, wait for it, 2. We're going to call that distance 2. Thank you, guys. Entertain me a little bit here. What else? Do we want to be triggering this on the same ultrasonic sensor?
No.
Thank you. So we're going to have to trigger echo pin 2 and trigger pin 2. Okay. So what we're doing now, this is why we've cleverly developed this in a separate function. Okay, had we written this in the code, we would have had to write digital write trigger pin 2 and trigger pin high. Here we are passing in to our function trigger pin 2 and echo pin 2. Okay, into this function. So this function stays the same, but we can pass in either trigger pin 0 or echo pin 0 and trigger pin 2 and echo pin 2 to trigger our second ultrasonic sensors using just one line of code. Genius, you cry. Okay, so now we're going to do our if distance is greater than 50, digital write LED 1 high. Okay, that's fine. Now we're going to pose an else if, right? Notice I was teaching this earlier. It's almost like it all comes full circle. It's almost like I plan these things out. If distance, can anyone guess what I'm going to put here?
2.
2, thank you. If distance 2 is greater than, someone give me a number.
51.
51, greater than 51. What are we going to do?
Do the opposite of the thing before.
We're not going to do the opposite. We're going to turn on our second LED. Okay.
LED 2.
So we're going to copy this piece of code, street smarts. And LED 2, thank you for whoever yelled that out. I'm going to turn that high. Here, we're going to say, oh, and Ross going to, I need to think about this carefully, how this code's going to run out. So if distance is greater than 50, digital write LED 1 on there, digital write 2 high. Otherwise, if both these conditions are not true, I'm going to turn both of our LEDs off. Okay.
Would it make a difference if you put distance 51 in brackets or not?
I don't think so. As long as you went like that.
Oh, okay.
If you do this, then this bracket doesn't have a close. Yeah. Okay. So let's try this out and see what happens. I'm kind of intrigued because we have kind of a weird operation going on here. But we start a simulation. Oh, what is this? Oh, have I spelled distance wrong?
It's coming up for me as well. But
Distance 2 is not declared in the scope.
Where is distance 2?
Oh, have I spelled
It's been
distance?
declared up top.
You haven't given it an inch.
Oh, yeah, okay.
Yeah,
So
it hasn't. Yeah.
up here, we need to declare distance 2. I got way too excited. Sorry about that, people. You're going to declare a distance 2. We're going to restart our simulation, and it's going to work perfectly. Right, and so now we're going to set this one high and this one low. Okay.
We're trying
So
to printing.
We're printing the first one. We're printing this one, 66. Okay, so this one now goes low. Lower than 30. That's going to turn off because it's too hot. Right. And this one we're going to drag up and the other LED is going to go on. If neither of them are true, which that one's not anymore, it's going to slowly turn off. Oh, wait, sorry, it's too close. Okay. Both of them are off. Fantastic. So we've managed to get 2 sensors. You can now expand this to 3, 500, but you're obviously going to run out of pins on your Arduino Uno. So yeah, cool. This is step done. Well done, everyone. You've learned how to run if statements.
sorry, Ben.
Yes.
Yeah.
I keep getting errors.
What, in your code?
Looking.
Yeah. I'll put in a screenshot. It's towards the
Okay.
end.
Ali's going to look at that. Rob and Ali are going to look at the code. I'm going to move on because I have things to cover. Do people want to stop here, or do you want me to run over how to do robot programming on a virtual software?
Can we
On
do
your-
that? Can we push on?
Yeah.
You want to push on?
Yeah.
On your else if there is
Okay.
no curly brackets.
So guys,
The
I'm going to
wrong way
show
around.
you how to program a maze solver. If anyone is wanting to stop, then by all means, you can leave now and watch this at a later time. But there will be kind of a competition running through the week on this. For those that want to stay, this will probably be another hour now. Feel free to stay and we'll cover this and you can ask questions and have live feedback. Okay?